Good evening, friends. Myself Gautam Sarma. I welcome you all in a Sapience Education. So, for more information, you can visit our website as well as you can take contact number. And today I'm going to do chapter electrostatics for potential and capacitance. I've already done chapter one, so you can go and read that chapter. So, today I'm going to discuss more, mainly focus on the theoretical part. Let us go topic by topic. So before that, we need to understand what is electrostatic potential energy. What is electrostatic potential energy, right? So we know that potential energy means what we have already learned, or you have already learned that potential energy is equal to mgh. Okay. Why this mgh has been done as a potential energy? Let us consider there is a object and you want to lift this object to this height. So when you put this object to this height, so you have done work. You have done work. Let us suppose we have done work of 100 joule. So the potential energy stored in this object will be 100 joule. It means that whatever work has been done, so this will be converted into potential energy. Now same things happens here also. In here, what happens? Electrostatic potential energy of a charge Q at a point in an electric field is equal to work done by external force in bringing a charge q from infinity to that point without an acceleration. Now see here. Suppose there is a charge q is placed and there is a another small charge which is placed at infinity. It is placed at infinity. Now no force is there. No force is there, right? Now as soon as I will move toward this, so what will happen? As soon as we will move toward this, so what will happen? We have to apply a force, and this will be a constant force, right? Constant force. So it means that if we apply a force, so we have to do work. So work done is equal to force into displacement, and this work done is gets converted into the potential energy of the system of two charges when the charge q and small q both are far away at a distance of r. So we can directly tell that work done in bringing a small charge from infinity to the point P, which is at a distance of r from a capital Q charge, right? So I hope you have understood, right? So potential energy is equal to work done. Potential energy at a point P or the system of the charge Q and small q is equal to work done in bringing an object from infinity to that point P. Now, when you work does, so you are applying a force on this. So this is known as external force. So let us suppose you have applied an external force here, external force in this direction. So external force into the displacement dr. Let us consider a small displacement dr. It has traveled. See, if you want to see here, so this, let us suppose this is a point P in this and this. So this distance dr has been moved. Now as soon as you move, so what will happen? The force required to move will increase as you reach nearby, so the force may increase. That's why we are using integration, right? Now tell me how much amount of the force will be applied to this. So the force will be how much? See, let us charge q is there. let us charge let us charge q is there. Let us charge q is there, and let us charge small q is there. So what happens when you move this charge? So what will happen? There will be a force between these two charges, and the force is known as electrostatic force, and this is equal to k q1 q2 by r square. So here k q1 is your capital K small q by r square, that is this distance. So this amount of force we will apply, right? Now it means that the potential energy can be written as up is equal to negative of the work done, that is equal to p into fe dot dr. Why negative? See here that electrostatic force, if both are positive, so electrostatic force will always act in this direction, but external force is acting on this direction. It means that in place of external force, if you are putting electrostatic force, so we have to put here negative sign. So finally we have put here negative sign, so finally we have got this as a potential energy. I hope you have understood now, right? Now let us go for a electrostatic potential energy difference between 2 points A and B is equal to the minimum work done by external force to move a charge Q from A to B. See here, same thing happens. Same, if you consider the same scenario, if you consider the same scenario, let us suppose there is a charge Q, and at a point A, there is another charge Q, and this is a point B. Now what happens? What happens? What will be the change in a potential energy? See here, potential energy at A is UA and potential energy at B is UB. So the change in potential energy will be UB minus UA, and this will be work done in bringing a charge from A to B, right? So here we can directly write change in potential energy is equal to work done in bringing a charge from A to B, and this is equal to what happens, external force we have applied into dr, and it travels from A to B, right? It travels from A to B. It travels from A to B because we are putting a charge from A to B. So this can also be written as A to B F electrostat, but negative. Why? Because it will always act opposite to the applied the force. So finally, change in potential energy can be written as integration of A B into force A dr. So this is what all about. So note, work done by electric field in moving charge does not depends upon the path. So it is path dependent, path independent. I hope you have understood now. Now let us go for electrostatic potential. Now you have studied about, first of all, electrostatic potential energy. After that, electrostatic potential difference, energy difference, and now we will discuss about electrostatic potential. What is electrostatic potential? See, potential at a point in a field is defined as the amount of work done in bringing a unit positive charge, very important, unit positive test charge from infinity to that point. So let us consider there is a charge, capital charge Q, and I want to find a potential at a point A, and we can consider this as a BA, right? Now let us suppose at infinity there is a unit positive charge, that is Q naught. Now I want to move this. Now I want to move this unit positive charge from infinity to that point, right? Okay. So what happens as per the potential is concerned? So potential is equal to work done by unit charge. So let us suppose the charge itself is a unit charge, right? So what happened? So when you bring this charge, so what will we have to do work? So work done in bringing a unit test charge, not charge. You can't take 2 coulomb, 5 coulomb, 10 coulomb. We will consider only unit charge, that is 1 coulomb, right? So work done in bringing a unit positive charge from infinity to that point is known as the potential at that point. So potential at that point is equal to W infinity to P and divided by Q naught. Okay. So Vp is equal to Up by Q naught. That is your potential energy only. Potential energy per unit charge. So this is the potential, right? Potential means capability. Potential does not depend upon external charge. Potential does not depends upon external charge. What do you mean by this? See here, no matter how much charge is at an external, if you want to find a potential, you have to use unit test charge. For example, this Q charge is equal to 10 coulomb. Now, due to 10 coulomb, what is the potential at this point? So, it may be 10 volt, 5 volt, but it does not depend upon the external charge. Why? Because whatever charge you will take, I will only consider 1 coulomb charge. For example, you have taken 5 coulomb charge and you have done the work done, for example, 100. So the potential at a point A is can be written as work done by in bringing a charge divided by 5 coulomb. So this will be how much? 20 20 joule per coulomb. It means that how much work is done in bringing a unit charge, 1 coulomb. In 1 coulomb, we are not talking about the multiple coulomb at all, right? So I hope you have understood now. Potential always consider a unit positive charge. So you will consider per coulomb only, right? Per coulomb only. If you increase, see here, if you increase the charge 10 coulomb, so what will happen? Work done will become more. So work done will become more. For example, if you double the charge, so work done become 200, right? And but the charge is 10. So what happen? You have to divide it by 10 to find the potential. So this will be again 20 coulomb per 20 joule per coulomb. As soon as you are increasing the charge, so work done is also increasing. So it means that potential does not depend upon how much charge you are bringing, but it only depends upon the external charge. It is not dependent upon the outside charge, right? So I hope you have understood this. Now let us go for a potential difference. Now that is very simple. Okay, we have already taken Q, and let us consider there is a point B and there is a point A. So let us consider potential at a point BB and potential at a point is BA. So what is the potential difference? So potential difference, we will tell that potential difference at a B minus potential difference at A. Now we have already done work done. Work done in potential is what? Work done by charge, unit charge. So work done what? In bringing a charge from A to B, so work done A to B divided by Q naught. So this will be potential energy B minus potential energy at A divided by Q naught. So I hope you have understood this, right? Now this is an scalar quantity because it does not have any direction, and SI unit is joule per coulomb or volt. We can say that it is a volt. Not a dimensions. We are talking about the dimensions. So what is the dimension of this? So basically, if you go and calculate, so this is work done by charge. So this will be mass ml square t minus 3 into ampere inverse. So I hope you have got this. Okay, you have got this. You have understood this concept, right? Now let us go for another thing, that is electrostatic potential due to point charge. Now see here, very important. So this derivation will come to your board exam. Now see here, there is a charge, positive charge, that is Q, and there is another charge here, right? So it may, and there is another charge, and it is a test charge, that is unit charge. So force on a test charge due to source charge at a Q at a point A is F is equal to K Q1 Q2 by R square. Understood or not? See, let us consider there is a test charge at this point and there is another charge Q. Now the force between these two objects, that is electrostatic force, is equal to K Q into small q by x square. Now the small work done in a small displacement. If the small displacement, I am talking about a small displacement only, that is dx. So the small work done will be force, electrostatic force into dx. And the force, electrostatic force and dx, what will be the angle? See here. If charge is there, let us see here, try to understand. Electrostatic force will act in this direction, but our displacement is this direction. So angle theta is equal to 180 degree. Now, if theta is equal to 180 degree, so I have put here 180 degree. So finally, the small work done in moving a charge, test charge from one point to another is dw is equal to minus fe dx. Now the total work done to move the charge from infinity to point P is how much? So we have to use this. How you will do this? See, it is very simple. So we need to put the values. So force, what is the electrostatic force? It can be written as minus K Q into Q naught by x square into dx. Now, if you want complete work done from infinity to point R, so what happened? We have to put the limit size from infinity to R. So the work done will be equal to minus K Q into Q naught into x to the power minus 2 into dx. When we calculate this, so we are getting this. And if we put the limit, so finally work done is equal to K Q into Q naught by R. So this is the work done. Remember, this is only R not R square. Okay, most of the students confuse here. So by definition, potential is equal to work done by Q naught. So potential is equal to KQ by R. Why? Because W is equal to KQ into Q naught by R. So potential is equal to W by Q naught. So this will be equal to KQ into Q naught by Q naught into R. So Q naught get cancel out. So velocity B is equal to, sorry, potential B is equal to KQ by R. So here we have got two formula. Okay. What we have got the two formula. First formula is work done. Work done will be equal to K. K in place of K, you know that we have already done some parts in a electric field chapter. So here work done is equal to K. K means 1 by 4 pi epsilon naught into Q naught pi R. Now what about potential? So potential will be equal to 1 by 4 pi epsilon naught into Q by R. So this is basic difference between work done and the potential. I hope you have understood this slide. Okay. Now let us go for next one. Now see potential at a point due to, yeah, before that I want to know that potential, if what is the symbol for the potential? If Q is positive, potential will be positive. So directly put here, if Q, that is charge, is negative, so potential will be automatically negative. Right? Now let us go for the next one. What do you know? Potential is your scalar quantity. Potential is your scalar quantity. Okay? Now see here. By superposition principle, potential at a point due to group of electric charge. See here. I want to know the potential at a point P due to charge Q1, due to charge Q2, due to charge Q3, due to charge Q4, it may be multiple one. So what we will do? We have to add by superposition principle. So net electric potential will be equal to V is equal to V1 plus V2 plus V3 plus dot 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 Vn. Now in place of V1, we can put here KQ Q1 by R1 plus K Q2 by R2 plus K Q3 by R3. Just we put here respective values. So finally we have KQ Qn by Rn. Now if we add this, so K will be common, but what will be not common, that is equal to Q1 by R1. So this will be add on up to Qn by Rn. Now, why don't we make it as a formula? So here I have already given the formula. So the formula V, total potential will be equal to K summation of I starts from 1 to N charge in is Qi divided by N. Right? Not N, or you can write here not N, this will be Ri, right? Ri. Again, I am writing you the formula B is equal to K summation of I is equal to 1 to N Qi by Ri, right? So this is the formula for that potential due to multiple charges, right? Potential at a point P due to multiple charges. So you have to take different distance for different charges because they are situated at a different places, right? Now let us go for next one. See here, variation of potential with the R is in blue curve and the field with the R in a black color. So let us go and write the formula for potential. So this will be equal to KQ by R. So potential is inversely proportional to R. So VR is equal to constant. So this will form a hyperbolic curve. Hyperbolic curve, right? So this blue curve shows you the potential variation. Blue curve shows the potential variation, right? With the distance or a radius 1 by R or 1 by R square. Okay. For electric field E is directly proportional to 1 by R square. So see here, electric fields comes like this and cross each other here only. Here only. So I hope you have understood now. Got it? So I hope this is all for today session, and I will recover most next topic in the next session. I hope you have understood. So this is part 1 video. So continue for continuous video, subscribe the channel so that you can get the regular updates. Thank you.